If the light from a star has travelled for billions of years to reach your eyes tonight, the strangest thing is that along its own path, time has almost never passed at all. Welcome to Drift into Quiet Knowing. Tonight we'll step into a very quiet question, but also a very deep one. Why does light not grow old the way we do? When you look up at the night sky, a tiny point of light may not be as tiny as it appears. It may be a ray of light that left a very distant star long before many human lives began and ended. It has crossed the cold emptiness of space, passed through cosmic dust as thin as a breath, moved through the darkness between the stars, and travelled across regions of space so vast that even imagination falls silent. But when that light reaches you, it has no grey hair, no wrinkled skin, no tired heart, and no heavy layers of memory the way human beings do. We grow old because we are matter with mass. Every heartbeat, every breath, every dividing cell, every memory held inside the brain is a trace of time passing through the body. A leaf turning yellow, a candle slowly burning down, a hand changing over many years, all of these remind us that matter lives within the flow of time. But light is different. Light has no body to age, no cells to wear down, and in the theory of relativity, the path of light has zero proper time. To put it gently, light does not pass through time the way we pass through life. In today's video, you will follow a small ray of light from the moment it leaves a distant star, travels through the darkness of the universe, and finally touches the eye of someone sitting quietly in the night. We will slowly come to understand why time is not the same for everything, why light can carry a message from the distant past without aging like a living body, and why the question of light is also, in truth, a question about age, memory, existence, and the fragile feeling of being human. Lie down comfortably, let your shoulders soften, and allow your breath to slow down a little. Stay with this journey until the very end, because once you understand why light does not grow old the way we do, you may begin to see time, life, and yourself with a very different kind of peace. Let us begin with what is closest to us before we look up at the distant stars. On the bedside table, a clock is still quietly counting each beat. In the dark room, someone's breathing is slowing down. Outside the window, a leaf that was once lush and green may have begun to turn yellow after many days of sunlight, wind, and rain. A candle, if it were lit, would grow shorter little by little, not because it knows what time is, but because its wax is changing into heat, light, and thin smoke. These images are very ordinary, but they're all telling us the same thing. Everything made of matter, when it lives inside time, leaves behind traces of change. Human beings are the same. We do not grow old simply because the calendar turns from one year to the next. We grow old because every cell in the body is working, repairing, dividing, using energy, being affected by the environment, and sometimes making very tiny mistakes that the body cannot fully fix. Old age does not live only in grey hair, in wrinkles around the eyes, or in the feeling of being more tired when walking up the stairs. Old age is a very long story written at the molecular level. It begins with things so small that the naked eye could never see them. A molecule becoming oxidized, a piece of genetic material being damaged, a protein folding into the wrong shape, a mitochondrion inside a cell working less well than before, a cell becoming too tired to keep dividing, and choosing to enter a state of senescence. This may sound dry, but if we tell it slowly, it becomes like the story of an ancient city. Your body is a living city. The heart is a pump station that never rests. The lungs are doors that exchange with the air. The blood vessels are roads. The brain is a sky full of electrical and chemical signals. The cells are small houses where countless quiet tasks happen every second. When the city is young, it repairs roads very quickly, replaces bricks very skillfully, clears away waste very steadily, and puts out fires in time. But over many years, tiny cracks begin to appear. Some roads take longer to repair, some machines inside the energy factories work less strongly, some signals become noisier. The city is still alive, still glowing, still beautiful in its own way, but it carries the marks of time in a way that cannot be denied. That is the first thing we need to understand before asking why light does not grow old the way we do. Because growing old is a property of complex material systems that are changing through time. A human body does not merely exist, it is always operating. it is always exchanging matter with the world. It eats, breathes, sleeps, wakes, heals, wounds, fights infection, creates memories, forgets some things, learns other things, and uses energy to keep itself alive. Even when you lie still in the dark and it seems as if nothing is happening, inside the body there is still an ocean of activity. Blood is still flowing, nerve cells are still sending signals, the immune system is still patrolling, the liver is still processing substances that need to be metabolized. The body is never truly still, and because the body is not still, it needs time. Without time, there would be no first heartbeat and then second heartbeat. Without time, there would be no wound forming and then healing. Without time, there would be no cell being born, growing, working, and then stopping. Life is a stream of processes. It is not like a stone statue sitting motionless in a museum. It is like a piece of music being played. Each note needs a moment to sound, then fade into silence, making room for the next note. The body is the same. It is the music of matter, and age is the way that music gathers traces through each passage of time. Imagine that you have a very special diary. Every day, you do not need to hold a pen and write anything, but your body still writes in it. A sleepless night is written through the tiredness of the nervous system. A long sunny season is written through darker skin. An injury is written through a small scar. A stressful period is written through heart rate, hormones, sleep, and the ability to recover. A beautiful memory is written inside the neural network, not as a fixed photograph, but as a pathway that has been travelled many times in the brain. These traces are not separate from one another. They pile up gently or heavily, creating the very human feeling we call "I have lived through many years." At the cellular level, that story becomes even more delicate. Each cell carries internal instructions for making proteins, controlling activity, repairing errors, and coordinating with other cells. But genetic material is not an indestructible book. It can be damaged by natural chemical reactions in the body, by radiation, by toxins, by errors during copying, or simply by the wear and tear of living processes. The body has very intelligent repair systems, and most of the time they work so quietly that we never know they are there. But over many years, some damage still accumulates. Some cells repair themselves, some cells destroy themselves to protect the body, and some cells enter a state of senescence and no longer work the way they once did. A senescent cell is not like an old person resting in a garden. It is a cell that has realized that continuing to divide could be dangerous, so it stops. To some extent, this helps prevent damaged cells from multiplying too much. But if too many such cells build up in tissues, they can change the environment around them. They send out chemical signals that affect inflammation, tissue repair, and the way other cells behave. So aging is not just each separate part growing weaker on its own. It is like a large orchestra, where some instruments begin to fall out of rhythm, and that change in rhythm makes the whole piece of music sound different. Then there are the mitochondria, the small structures often called the energy factories of the cell. They help turn energy from food into a form of energy that the cell can use. But the process of creating energy also comes with side effects. Over time, mitochondria may become less efficient, and when energy inside the cell is no longer managed as well as before, many other functions are affected too. A person may not feel each mitochondrion in the body, but when billions of tiny processes change together, we feel it as being more tired, recovering more slowly, or no longer being as resilient as we were when we were young. This does not mean the body is only a machine slowly breaking down. The living body is far more miraculous than that. It can repair, adapt, learn, and recover. A wound can close. Muscles can become stronger when trained properly. The brain can create new connections. Sleep can help regulate many biological processes. Life does not simply surrender to time. Life is always negotiating with time. But the very fact that it has to negotiate shows that we belong to the world of matter with mass, where everything needs energy, needs order, needs repair, and no order can be preserved forever without effort. There is a very deep idea here, but let us step into it gently. In physics, material systems often tend to move from a more ordered state toward a less ordered state if there is no energy to maintain them. A room, if it is not cleaned, gradually becomes messy. A hot cup of tea placed on a table slowly cools down. A sandcastle on the beach is reshaped by wind and waves. The living body is a miracle because it resists that falling apart for a long time. It maintains temperature, structure, biological rhythm and chemical balance inside itself, but to do that it must constantly use energy. When the systems that repair and maintain the body are no longer as strong as before, the traces of time become more visible. So when someone says, "I am growing old," that sentence is not only a feeling, it is also a physical and biological truth. That body has moved through time by using energy, exchanging matter, suffering damage, repairing damage, storing memories, and changing little by little. A person was once a child, then they became an adult. Then they look back at the old years with a very strange feeling. Somehow, I am still myself, but my body has changed, my mind has changed, and my way of seeing the world has changed. Age is not counted only on paper. It lives in the way a hand holds a cup of tea, the way the eyes look at an afternoon, the way the heart responds to a song once heard long ago. Now, place that story beside light. A ray of light has no heart to beat, no lungs to breathe, no cells to divide, no genetic material to make copying errors, no mitochondria to create energy, no immune system to weaken, no brain to remember a distant summer, no body to carry scars. If a ray of light travels from a star to your eye, it does not travel like a wanderer carrying a backpack, growing more tired with every mile. It does not take step after step. It does not need to rest. It does not drink water. It does not become older after each year in the biological sense, because it is not a living being, and it is not a complex material system like the body. But the question does not stop there. If we only say that light does not age because light is not alive, the answer is still too shallow. A stone is not alive either, but a stone can wear down, crack, weather, and be changed by water and wind. A book is not alive, but its paper can turn yellow, its ink can fade, and its spine can decay. A chair is not alive, but wood can bend and metal can rust. Non-living things can still age in a material sense, because they have structure, mass, internal states, and they are affected by the environment over time. So what makes light different from them? That difference leads us to the deepest part of the question. Light does not only lack a biological body, light in a vacuum also moves in a special way through the structure of space and time. For us, time is something we feel very clearly. An hour of waiting can feel long, an hour of joy can feel short. But a physical clock still measures a passage of time in our lives. For matter with mass, there is always a kind of proper time attached to its journey. A person sitting in a chair, a ship flying through the sky, a stone resting on the ground, all of them can be imagined as carrying their own clock. That clock measures the time that passes along that object's own path through space-time. Light is different. In the theory of relativity, the path of light is a special path. We cannot place ourselves in a reference frame that is at rest with a photon the way we can imagine sitting still on a ship. A photon does not have a rest state like a chair or a stone. But in the geometric language of relativity, we can say that the proper time along the path of light is zero. This is a very short sentence, but it opens a deep valley of thought. It means that between the moment light is emitted and the moment it is absorbed, within the structure of light's path, no proper time passes the way time passes inside our bodies. Notice this difference slowly. For a human being, the longer the journey, the more traces it usually leaves. A person who moves through many years will gather more memories, more changes, more losses, and more growth. A boat crossing the ocean may have its hull corroded by sea salt. A paper letter travelling through many decades may turn yellow. But for light, the journey through empty space is not like a biological trip or ordinary material aging. Light can be absorbed, scattered, bent by gravity, or have its wavelength stretched as the universe expands. But that is not old age in the sense of a body gradually wearing down from within. Those are traces of interaction and of cosmic geometry. When we understand this, we begin to see that the question, why does light not grow old the way we do, actually has two layers. The first layer is very close to us. We grow old because the body is a complex biological system, always operating and always changing. The second layer is deeper. Light does not have proper time like we do along its journey through a vacuum. A ray of light does not experience its path the way a person experiences a lifetime. It does not have an inside that is slowly wearing down. It does not have a biological diary being written day by day. It is a propagation of the electromagnetic field, a piece of information and energy moving at the deepest limit of nature. Imagine that two things begin from the same distant star. One is an imaginary ship with mass, carrying an astronaut. The other is a ray of light emitted from the surface of the star. No matter how fast the ship flies, if it has mass, it still cannot reach the exact speed of light in a vacuum. The astronaut on the ship still has proper time. Their heart still beats. The clock on the ship still runs for them. Their body still needs food, water, sleep, and it still undergoes biological processes. But the ray of light is not like that. It does not carry a small cabin with a wall clock inside. It does not have its own mornings and evenings. It does not pass from youth into old age. It simply travels, in the way light travels, until it meets something and gives its energy to that thing. Perhaps this is why light feels both scientific and mysterious to human beings. Not mysterious in a superstitious way, but mysterious because it touches questions that are too large. What is time? What is age? What is existence? And why do we feel our lives as a flow? A ray of light from a distant star does not know how long it has travelled, but we know. We look at it and say, this light has taken so many years to arrive here. We use our clocks, our history, and our distances to call it ancient light. But light itself does not grow old the way the person who looks at it grows old. A person may stand beneath the sky at the age of 10, then stand there again at the age of 70, and feel that they have changed so much. But the light from distant places, when it reaches that person's eyes, still does not carry old age like a living being. That does not make human beings smaller. On the contrary, it makes human beings more moving, because the very fact that we age proves that we have lived inside time. Light may have no wrinkles, but light also has no memory of one hand once holding another hand. Light has no longing. Light has no forgiveness after many years. Light does not know what it feels like to sit quietly in the night and hear a question soften the heart. We grow old because we belong to the world of experience. Every mark on the body is a kind of record. Every change in the mind is a sign that time has passed, not as an empty number, but as a real river touching the shore. Let us return to the clock on the table. It is still ticking evenly, but the way we feel it is never completely the same. When we are young, 10 years can sound like something very far away. When we are older, 10 years can pass like one long breath. This belongs to psychology and memory, but beneath it is still biology. Our brain changes through experience. Neural connections are strengthened or fade away. Important events become milestones. Ordinary days blend together like mist. We do not only live in physical time, we also live in the time of memory. And that inner layer of time makes human aging completely different from a ray of light. A ray of light does not look back and remember where it was born. If it leaves a brilliant blue star, it does not remember that blue. If it passes near a cloud of cosmic dust, it does not marvel at the shape of the cloud. If it is briefly blocked by a distant planet, it does not experience darkness as fear. Only when light meets an eye, meets a retina, meets a nervous system, meets a brain that can build images and meaning, does it become part of living experience. Light by itself does not tell a story, but when it touches a living being that has time, it becomes a story. It becomes the night sky, becomes a childhood memory, becomes a feeling of peace, becomes a question that makes us lie still and yet feel that we are travelling. And so the answer begins to appear more clearly. We grow old because we are living matter, with mass, complex structure, energy exchange, repair and damage, memory and emotion, and proper time running through every day of our lives. Light does not grow old the way we do because it has no body to wear down, no biological system to accumulate damage, and more deeply, in the theory of relativity, the path of light does not contain proper time in the way the path of matter with mass contains proper time. It does not step through the years as we do. It does not live inside the biological flow of age. It belongs to another rhythm of the universe, a rhythm we can only understand through mathematics, physics, and a little silence in the soul. But the stranger thing is this: light does not merely lack a body that can grow old. In the theory of relativity, the very path of light also does not contain proper time the way our path does. If the human body is a diary written with heartbeats, cells, memories, and very small changes, then light is like a message launched along the deepest edge of spacetime. To us, it may take millions of years to arrive. To the universe, seen through the geometry of light, that journey carries an almost absolute silence about proper time. And from that difference, we're about to step into an even deeper question. What is light, really, and why is it unlike any ordinary object we have ever touched in life? And now, after seeing the human body as a living diary written in heartbeats, cells, and memories, let us turn to something that seems more familiar than almost anything else, yet is also one of the strangest things of all: light. Maybe right now, somewhere around you, there is still a very soft bit of light resting on a wall, on the edge of a table, on a curtain, or on your hand. During the day, it comes through a gap in the door like a thin strip of gold. At night, it may come from a small lamp, from a screen in the distance, or from a quiet star outside the window. We see light every day, so often that we almost stop asking what it is. But if we slow down and stop for just one question, that question is enough to open up an entire abyss. Light is not like a rock, not like a drop of water, not like a leaf. So what is it really that allows it to travel through the universe for so long without aging the way we do? When we were children, it was easy to imagine light as tiny golden dust particles floating through the air, or as thin arrows shot out from the sun. That image is not completely useless, because light really can arrive in small packets called photons. But if we only imagine a photon as a tiny marble flying through space, we can easily misunderstand the strangest thing about light. A marble can sit still in the palm of your hand. A grain of sand can lie motionless on a beach. A leaf can fall to the ground and then stop. But light in a vacuum does not exist in that kind of way. It has no state where it sits still beside us. It cannot be placed on a table like a small object so we can look at it from every angle. It does not slow down to rest. It does not begin as something standing still and then gradually speed up. In a vacuum, light always appears at the speed of light, a speed that sits at the very center of modern physics. Imagine that one morning, a beam of sunlight passes through a gap in the curtain and falls onto the floor. We see a calm patch of light, and it seems as if it is just lying there. But in reality, that stillness is an illusion created by our eyes. Light is not lying still on the floor. Photons from the sun have traveled through space, passed through the atmosphere, entered through the window, and then been absorbed by the floor or reflected into our eyes. What we call a peaceful patch of sunlight is the result of countless extremely fast events happening continuously. Tiny portions of light arrive, touch, change direction, turn into heat, or send signals into the eye. It is like looking at a stream from far away and seeing the surface of the water as a still strip of silk. But if we reach out and touch it, we know every drop of water is moving. Light is electromagnetic radiation. That sentence sounds very scientific, but we can understand it in a softer way. Light is a vibration, a spreading motion of electric fields and magnetic fields through space. Electric fields and magnetic fields are not strings or smoke that we can grab with our hands. They are physical fields, meaning that at every point in space, nature can carry a certain value, direction, and strength. When those fields oscillate and sustain each other, they form electromagnetic waves. The light that human eyes can see is only a very small part of the enormous family of electromagnetic waves. Beyond the visible range, there are radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. They differ mainly in wavelength and frequency, like different notes played on the same cosmic instrument. This is very important for our question. Light is not a small chunk of matter, flying through space like a pebble that has been thrown. It is the propagation of the electromagnetic field. When you turn on a lamp, light does not pour out like sand from a bag. It is emitted when charged particles inside matter change their energy states, and that energy then spreads outward as electromagnetic radiation. In an old incandescent light bulb, the material heats up and emits light. In a star, physical processes inside it and on its surface produce radiation. In an atom, when an electron moves from a higher energy state down to a lower one, the difference in energy can be emitted as a photon. Every source of light has its own story, but once light enters empty vacuum, it carries a special nature. It moves at the speed of light. If you throw a rock, the rock needs force in order to accelerate. It has mass, it has inertia, and it can move faster or slower. Without a force acting on it, its motion still depends on its earlier state. If it hits a wall, it stops or breaks apart. A rock can sit in a bag for years. It has a way of existing that is easy for us to picture. Here, then there, able to be still, able to move. But light is not like that. A photon has no rest mass. That phrase needs to be said carefully. It does not mean light has no energy. On the contrary, photons have energy and momentum. Light can warm your skin, create a very tiny amount of radiation pressure, make solar panels generate electricity, affect matter, and under certain conditions push imaginary light sails through space. But a photon does not have rest mass like a rock or a human being. It cannot be brought into a state of rest so we can weigh it the way we weigh an ordinary object. This is where we begin to sense why light does not age the way we do. A body with mass can carry its own proper time. A clock can sit on your wrist. A heart can beat one beat after another. A cell can go through a process of being born, doing its work, and then weakening. But a photon does not have an inner life the way a body does. It has no complex internal structure that slowly wears down. It has no parts that must coordinate in order to keep it alive. It has no little clock hanging inside itself. It has no resting state where we can say, here is the photon sitting still and waiting for time to pass. Its way of existing is different from the very foundation. We may hear this and feel a slight chill down the spine, not because it is frightening, but because it makes the familiar world feel strange. In the same room, the rock on the table and the light from the lamp do not belong to the same kind of existence. The rock is matter with mass and structure. It can stay still, wear down, crack, and carry marks left by time and the environment. Light appears only through motion and interaction. When it is not absorbed, it keeps propagating. When it is absorbed, it is no longer that same photon. Its energy has moved into matter, perhaps becoming heat, an electrical signal, a chemical reaction, or the experience of seeing inside the brain. Light does not age into an older version of itself. It either keeps travelling, or it interacts and transforms into another form of energy. Let us take a very concrete example. You place a book under sunlight for many years. The book will grow old. The paper may turn yellow, the ink may fade, and the cover may bend. The book ages in a material sense because the molecules in the paper and ink are changed by heat, moisture, oxygen, and light itself. But the light shining on the book does not age in that same way. It does not become old light because it has been shining for a long time. When a photon meets a molecule in the paper, it may be absorbed. Its energy changes the state of that molecule, and the story of that photon ends in its old form. Another photon arriving afterward is a new event. So the aging of the book is the accumulated history of matter. Light, by contrast, does not collect wrinkles inside itself the way paper collects yellowing. Another example is closer to everyday life: sound. When you speak in a room, sound needs air in order to travel. It is the compression and expansion of air molecules. Without air, sound cannot travel in the familiar way. That is why, in the vacuum of space, we cannot hear explosions the way movies often show them. Sound needs a material medium because it is the collective motion of particles in that medium. But light does not need air to travel from the sun to Earth. The space between celestial bodies is extremely thin, almost empty by ordinary human feeling, and yet light still crosses it. It does not need an ocean of air to float on. It does not need molecules packed together to pass along a message. It is an electromagnetic wave that can travel through a vacuum. This alone is enough to make light the strangest messenger in the universe. Light from the sun reaches Earth in about 8 minutes. That means when you feel warm sunlight on your skin, you're receiving energy that left the sun several minutes earlier. Light from the moon takes a little more than 1 second to reach our eyes. Light from a distant star may take tens, hundreds, thousands, or millions of years. For very distant galaxies, that number can reach billions of years. Because light can travel through vacuum, the night sky becomes an enormous archive. Not an archive made of paper, but one made of electromagnetic radiation. Every bright point is a message that has crossed space. Every ray of light is a piece of news from a place we cannot touch with our bodies. But we have to be very precise here. When we call starlight ancient, that is our way of speaking, from the perspective of creatures who have clocks, histories, and their own proper time. We say that light has travelled for 1,000 years because in Earth's frame of reference, the time between the moment it left the star and the moment it reaches our eyes is 1,000 years. but the light itself does not carry biological old age during that journey. It does not get tired after the first year and then grow weaker after the second. It has no muscles to become fatigued, no tissue to age, and no memories to pile up. And at a deeper level, because light moves along the path of light in space-time, its relationship with time is not the same as the relationship that an object with mass has with time. Even so, light does not always keep every feature unchanged during its journey. This point needs to be clearly separated so the story does not become too romantic. Light can be redirected when it passes through a lens. It can be scattered by air molecules, making the daytime sky look blue and sunsets look reddish-orange. It can be absorbed by cosmic dust. It can have its path bent by a strong gravitational field. It can have its wavelength stretched by the expansion of the universe, making light from distant galaxies shift toward the red. But those changes are physical interactions or effects of space-time. They are not like the aging of a living creature. They are not like the process of a body accumulating internal damage over the years. Imagine you have a musical instrument. When a string is short and tight, the sound is high. When the string is longer or looser, the sound becomes lower. With light, wavelength and frequency are also related to energy. Blue light has a shorter wavelength and a higher photon energy than red light within the visible range. When the universe expands, light from distant galaxies can have its wavelength stretched. It becomes redder, and each photon has less energy when we measure it. But we should not call that old light in the same way we call a human being old. More accurately, it is light that has travelled through changing space, and the change in space has been written into its wavelength. It is like a piece of music stretched out by the stage itself as the stage expands, not like a singer whose voice has become hoarse with age. Now let us return to the question of whether light is a wave or a particle. In everyday life, we usually separate these two images. A wave is like water spreading across the surface of a lake. A particle is like a pebble falling to the bottom. One is soft, broad, and spreading out. The other is small, has a specific location, and collides like an object. But in the quantum world, light does not have to look exactly like either of those familiar pictures. In some experiments, light shows wave behavior, such as interference and diffraction. It can create bright and dark bands like ripples of water overlapping each other. In other experiments, light transfers energy in separate packets, as photons, such as in the photoelectric effect. Nature does not have to fit inside the imaginary drawers of the human mind. Light is light, and wave and particle are only two ways we try to see it through our language. This dual nature makes light even less like an ordinary object. A chair does not create interference bands when it passes through two narrow slits in the way we observe things in daily life. An apple is not both a spreading wave and a discrete amount of energy in the ordinary quantum sense that applies to light. But light can force us to accept that, at the deep level of nature, familiar images are only approximations. It is like looking at the ocean from high above and seeing a calm blue surface, then moving closer and seeing waves, then looking deeper and seeing molecules, then atoms, then fields and quantum particles. Reality does not always look like the first image our senses give us. Light is one of the things that taught humanity that lesson most powerfully. And that lesson brings us back to the one big takeaway of this story. Light does not age the way we do because it does not belong to the same kind of journey as living matter with mass. A human being is a biological system with a complex structure, existing in time, exchanging energy, and accumulating change. Light is electromagnetic radiation, described in quantum physics as photons with no rest mass, always moving at the speed of light in a vacuum. A person can stop beside a window and watch the rain fall. A car can park under a roof. A rock can sit inside a mountain for millions of years. But light in a vacuum has no stopped life like that. It does not stay still so time can lay dust upon it. It is the act of travelling. There is something very beautiful inside that act of travelling. Light has no memory, but it helps memories form inside us. Light does not know age, but it lets us see the marks of age in the world. Light does not grow old like a body, but it can reveal the age of a star, the colour of a galaxy, the trace of an ancient explosion, or the curve of space-time around a heavy object. It is not a storyteller with a voice, but it is what carries the story to us. When a telescope gathers light from a distant galaxy, it does not hear the galaxy speak, but it can read in that light information about chemical composition, motion speed, temperature, distance, and sometimes even the history of stars that were born and then died. This makes light like a very strange letter. A paper letter can grow old, but light is like a letter without paper. It has no surface to stain, no edge to tear, and no ink to fade. It carries information through wavelength, frequency, intensity, polarization, direction of travel, and the way it interacts with matter along the way. When it passes through the atmosphere of a distant planet, part of the light is absorbed at certain wavelengths, leaving behind spectral fingerprints. From those fingerprints, humans can infer which molecules are present in that atmosphere. In other words, light does not need to age in order to become meaningful. It only needs to interact with the universe, then arrive at a mind that knows how to read it. Maybe this is why a tiny point of light in the night can calm the human heart. It is both physics and symbol. Physically, it may be electromagnetic radiation emitted by some faraway process. Emotionally, it is a point of contact between our present and the universe's past. A person sitting at night and looking up at the sky may be seeing light emitted before their very distant ancestors were even born, before familiar cities were built, before the human stories of today had even begun. But that light does not arrive like a tired old man. It arrives as itself, a quantity of energy, an electromagnetic oscillation, an event that touches the eye and wakes up inside the brain as an image. We should also remember that light inside matter can be slower than light in a vacuum. When it passes through water, glass, air, or other media, light interacts with particles in that medium, making its effective speed of propagation lower. That is why a spoon in a glass of water can look as if it is broken, or why a prism can split white light into many colours. But this does not contradict the deeper nature of light in a vacuum. In empty space, where there is no material medium blocking it in that way, light travels at the speed of light. When we say light does not age the way we do, we are talking about this fundamental difference. It is not an object with rest mass. It has no internal life like a body, and it does not carry proper time the way a person or a rock does. Try to picture a train platform at night. One person is standing still on the platform. A train passes by. A flash of lightning appears at the end of the track. The person standing still has their own clock. The person on the train has their own clock. Both of them can talk about distance, time, speed, and each of them has a valid frame of reference. But the light from the lightning flash is not a passenger who can sit in a private train car and describe what the world looks like while it is at rest. There is no train car that travels alongside a photon in a resting state. There is no chair reserved for light in its own frame of reference. This is very hard to imagine, but it is exactly why light leads us to relativity. It is not merely something very fast. It is something that reveals the deep structure of space and time. For ordinary objects, speed is something that can change continuously. You can walk slowly, then faster, then stop. A car can accelerate from rest to high speed. A planet has its own orbit. But light in a vacuum does not have that chain of experiences. It does not accelerate from zero up to the speed of light. It is emitted already moving at the speed of light. This is one of the points that confuses our intuition. Human intuition is built from life among things with mass. Stones, water, bodies, objects, vehicles, trees. In that world, things can rest, run, slow down, or speed up. Light refuses to fit neatly inside that intuition. It comes from a deeper layer of nature. And if we listen carefully, we will see that this does not make light more alien. It makes it more beautiful. Every morning, when light touches a room, there is not only sunlight in the poetic sense. There is a part of the universe expressing itself through electromagnetic fields. There are photons that have left the sun, crossed space, and ended their journey when they met a wall, a floor, skin, eyes, leaves, or water. A leaf uses light for photosynthesis, turning light energy into chemical energy. An eye uses light to create images. A solar panel uses light to create an electric current. Each time light interacts, it does not become a little older. It gives energy, gives information, and then transforms inside matter. So when we look at light through science, we do not remove its mystery. We only replace a vague layer of mystery with a more precise one. Instead of saying light is magic in a blurry sense, we see that it is magic in a deeper sense. A phenomenon that is both wave and quantum, has no rest mass, needs no air in order to travel, carries energy from the stars and relates to time in a way unlike any living body. A question that seems simple, what is light, eventually opens the door to another question, what is time? Because if light were only a tiny object flying very fast, we could imagine it aging less because it is moving faster. But the truth is much subtler. Light does not have the same kind of internal clock as matter with mass. And here, everything begins to connect back to the earlier part. The human body ages because it is a living material system, complex, always maintaining order through energy, and always leaving the marks of time in cells, tissues, memories, and emotions. Light does not age like that because it is not a biological system, and it is not an object that can sit still and accumulate damage. It is electromagnetic radiation. In the language of quantum physics, it is photons. It is the transmission of energy and information at the universe's speed limit. It does not sit inside time the way we do. It does not carry an inner lifetime. It does not go through youth and then old age. It can be absorbed, scattered, bent, and stretched in wavelength, but it does not age like a heart that has beaten through many seasons. If tonight you look at a small point of light on the ceiling, maybe it's only reflected lamplight, but inside that little point of light is a quiet lesson. It says the world is not made only of things we can hold. Some things exist by travelling. Some things do not need to stand still in order to be real. Some things touch us and then disappear, yet still leave an image in the mind. Light does not live a human life, but it allows human life to see. Light does not age the way we do, but because of it, we realise that we're aging inside a universe much larger than our bodies. And perhaps that very difference is what makes the original question so deep. Not why light stays forever young like a myth, but why time for light is not the same as time for us. To understand that all the way down, we cannot look at light only as a golden colour on the floor or as white brightness from a lamp. We have to take one more step into the idea that changed how human beings understand time. Because once light always moves at a fixed speed in a vacuum, once no one can sit still alongside a photon and see the world from its resting state, the idea of absolute time begins to shake. The clock is no longer one king ruling the whole universe. Time no longer flows the same way for every object, in every place and in every kind of motion. And that is when we meet Einstein, not as a distant name in textbooks, but as the person who helped humanity hear a very strange whisper from light. To understand why light does not age the way we do, we must first accept that time is not as simple as we once imagined. This is where we need to step into an idea that is both beautiful and deeply confusing to the human mind. Time is not a single river flowing evenly for everything in the universe. In ordinary life, we're used to thinking of time as a giant clock hanging outside all things. Whether you're sitting still, a car is moving, a planet is rotating, or a beam of light is racing through space, we often imagine that everything is under one shared rhythm of ticking. 1 second here is 1 second over there. 1 minute for one person is also 1 minute for another. But when light enters the story, that familiar intuition begins to crack very slightly, like a quiet lake touched by a single drop of water. Imagine two clocks that are exactly the same. They were made at the same time, placed side by side and set to show the same moment. One clock stays still on a table in a quiet room. The other is taken aboard an imaginary spaceship that can fly extremely fast, so fast that its speed begins to approach the speed of light. Before the spaceship leaves, the two clocks match perfectly. But after a long journey, when the spaceship returns and the two clocks are placed side by side again, they no longer show the same time. The clock on the spaceship may have ticked less than the clock on the table. This sounds like a mystical story, but it is not magic. It is physics. It is one of the deepest things relativity has told us. Time depends on motion. At everyday human speeds, this difference is far too small for us to feel. When you walk across a room, when a car drives down a road, when an airplane crosses an ocean, time still seems almost the same for everyone, because all of those speeds are far too slow compared with the speed of light. But the faster an object with mass moves, the closer it gets to the speed of light, the more slowly its time runs when compared with an outside observer. This is called time dilation. The phrase may sound dry, but its meaning is deeply strange. Time is not a rigid background. Time can stretch or compress depending on motion. A gentler way to imagine this is through a light clock. Picture a small box with two mirrors facing each other, one mirror on top and one mirror on the bottom. A beam of light bounces back and forth between the two mirrors. Each time the beam travels from one mirror to the other and back again, we can treat that as one tick of the clock. If the box is standing still in front of you, the beam of light goes straight up and down, and its path is very simple. But if that box is on a spaceship rushing sideways past you at a very high speed, you will see that the beam of light is not only moving up and down, it is also being carried along by the sideways motion of the spaceship. From your point of view, the path of the light becomes a longer diagonal path, and yet the speed of light in a vacuum must remain the same. If the light has to travel a longer path while its speed stays the same, then that tick of the clock must take longer. Seen from the outside, the clock on the spaceship runs slower. The strange part is that for the person on the spaceship, everything inside the spaceship still feels normal. The light in their clock still moves up and down between the two mirrors. Their heart still beats with its familiar rhythm. They do not feel frozen inside some special kind of time. They do not feel their seconds stretching like a pulled thread. To them, their own clock is still normal. This is what makes relativity both difficult and beautiful. It is not that one person is right and the other is wrong. Each person measures time within their own frame of reference. Each person has a way of slicing the universe into space and time according to their own motion. And when they meet again, that difference can become a real result on the clocks. Let us place this into a story that is easier to picture. An astronaut leaves Earth on a very fast spaceship, travels close to the speed of light for a long time, and then returns. For the people who stayed behind, many years may have passed. Trees may have grown taller, cities may have changed, familiar faces may have aged. But for the astronaut, less proper time has passed on the spaceship. That person may return younger than people of the same age back home. This is not because the astronaut stepped into some mythic dream, but because motion at extremely high speed makes the measured time between two parts of the journey different for different frames of reference. Time becomes part of the geometry of spacetime, rather than a shared clock hanging outside the universe. Here we need to stop for a moment and feel the difference between objects with mass and light. An astronaut, a spaceship, a speck of dust, a rock, a human body, all of them have mass. They can be at rest relative to some observer. We can imagine each of them carrying its own clock, measuring time along its path through space-time. That clock does not necessarily run the same way as someone else's clock, but it still exists as a way for that object to measure its own time. A person moving through life has proper time. A spaceship flying through the universe has proper time. An atom moving extremely fast inside a particle accelerator also has proper time. But light is not like that. Light in a vacuum always moves at the speed of light. There is no way to accelerate an object with mass all the way up to exactly the speed of light, because the energy required becomes greater and greater as its speed approaches that limit. A spaceship with mass can get close, but it cannot become light. A body can fly very fast in our imagination, but it cannot reach the exact speed of a photon in a vacuum. Light is not a vehicle that is faster than every other vehicle. It belongs to a different kind of path. In the geometry of relativity, the path of light is a path where proper time is zero. That sentence needs to be said very carefully, because if we say it the wrong way, we can turn science into an image that is too simple. We should not imagine a tiny photon wearing a clock, looking down and seeing that the hands of its clock have stopped. A photon has no valid rest frame. We cannot sit on a beam of light the way we might sit on a spaceship and ask, from light's point of view, what does the universe look like? That question falls outside the way relativity allows us to build a frame of reference. But in the mathematical language of spacetime, we can say that along the path of light, proper time is zero. Between the event where light is emitted and the event where light is absorbed, the proper time along the path of light is zero. If this sounds too abstract, let us return to a very ordinary image. When a person walks from the house to the garden, they can say, "It took me 1 minute to get there." During that minute, the heart beats many more times. The lungs breathe in and out, the muscles work, thoughts pass by. That person has truly experienced a span of proper time during the journey. If a spaceship flies from one planet to another, the clocks on board also measure some amount of time. But with light, the story cannot be told in that same way. From our side, we can measure that light takes about 8 minutes to travel from the sun to Earth. We can say that light from a star takes 1,000 years to reach our eyes. but we should not imagine the beam of light itself living through 8 minutes or 1,000 years the way a person lives through days and months. The path of light does not contain proper time in that way. This is exactly where the question, why does light not age the way we do, becomes clearer. We age because the body has proper time. Along the path of each person's life, biological processes unfold, cells change, memories form, tissues are repaired and then weaken, energy is consumed, years are written into the body and the mind. But light has no inner life that can record the passing years in that way. It has no personal clock in the sense that an object with mass has one. It has no inside that can grow old. And within the structure of relativity, light's journey from emission to absorption has zero proper time. This makes the night sky far stranger than it first appears. When you look at a distant star, you're seeing light that left that place a very long time ago, according to our clocks. Maybe the star has changed. Maybe it has swollen, cooled down, or perhaps no longer exists in the same state. But the light arriving at your eye is not old like a person walking across a desert. It does not arrive with a layer of time's dust on its shoulders. It does not carry the feeling of exhaustion after a long journey. It is simply light, carrying energy and information, travelling along the path of light through space-time, then touching the retina, creating neural signals, and finally becoming a bright point inside your awareness. The fact that time is not absolute has another layer. Gravity also changes time. If special relativity tells us that motion affects time, general relativity tells us that gravity affects time as well. The closer you are to an object with strong gravity, the more slowly time passes compared with a place where gravity is weaker. This sounds like a fairy tale about lands where clocks run differently, but extremely precise atomic clocks have measured this effect. A clock at a slightly different height from another clock can tick at an incredibly tiny but different rate. That difference is far too small for daily life to notice, but it is real. Imagine placing one clock at the foot of a mountain and another clock at the top. The clock on the mountain is a little farther from the centre of Earth, in a slightly weaker gravitational field. According to general relativity, it will run faster by an extremely tiny amount compared with the clock lower down. No one standing on the mountain suddenly feels that they live in another world. No one looks down into the valley and sees time flowing like honey. But when measured with instruments precise enough, the universe whispers that time is not exactly the same at every height. A place closer to a large mass has a very slightly different rhythm of time than a place farther away. What does this have to do with light? It shows that time is not a rigid and independent flow. Time is tied to motion, tied to gravity, and tied to the structure of space-time. Light, which always moves at the speed of light in a vacuum, is the key that opened this understanding. If the speed of light is the same for all inertial observers, then space and time must adjust in a way that goes against old intuition. We cannot keep the idea that every clock in the universe shares one absolute rhythm. In order for the speed of light to remain constant, time and space must become more flexible in the way they are measured. There is a very gentle way to say it. Light does not only illuminate the room, it also illuminates the truth that our time is not the only centre of the universe. Before Einstein, it was easy to think of time as the stage, while all objects were merely actors walking across that stage. But relativity changed the stage itself. Space and time are no longer two completely separate things. They form space-time. Every object with mass moves through space-time along its own path, and proper time is the amount of time that object measures along its own journey. Light, meanwhile, travels along special paths where proper time is zero. So light does not age like an actor passing through many scenes of a play. It is more like a strange boundary of the stage itself. Perhaps by now we begin to see why the original question is not simple at all. If we look with ordinary eyes, we see light as the thing that helps us see our hands, faces, cups, roads, and stars. But when we look through physics, light becomes one of the deepest measuring rods of reality. The speed of light is the speed limit for the transmission of information in the universe, according to modern understanding. No ordinary physical signal can exceed it in a vacuum. So light is not just something that moves extremely fast. It is the boundary between what can be causally connected and what cannot be reached immediately. It determines how the past can send signals into the present. Think of a star that is 100 light-years away from us. If you see it tonight, you are receiving light that left that star 100 years ago, according to Earth's clocks. That is not only a distance, it is the structure of information. You cannot know what that star is like right now in an immediate sense, because information cannot travel faster than light to reach you instantly. The universe does not allow every place to know every other place all at once. Every look up at the sky is a look into the past. And yet, strangely, the light carrying that past does not age the way a messenger grows old along the road. It is information arriving according to the deepest limit of nature. This creates a feeling that is both lonely and comforting. Lonely, because we realize that the present of the universe cannot be held completely in our hands. We are always seeing versions that have already departed. The sun we see is the sun from about 8 minutes ago. The stars we see may be stars from many years, many centuries, or many thousands of years ago. But comforting, because light prevents those distances from being completely silent. Even when space is so vast that human beings cannot cross it with their bodies, light still brings news. It is the way the universe sends letters to itself, and when that letter arrives, we, creatures with proper time, read it with our finite eyes. Relativity does not say that time is simply an illusion. We still age. Clocks still run. 1 minute of sorrow can still feel long, and 1 minute of peace can still feel short in our experience. But physics says that time is not an absolute quantity that is the same for every observer, in every kind of motion, and in every gravitational field. And that lack of absoluteness is exactly what allows us to understand light more deeply. Light does not age the way we do, not because it has been granted some mythic eternal youth. It does not age the way we do because it has no rest mass, no rest frame, no biological structure to change over the years, and because its path through spacetime has zero proper time. When we say that, we also have to be humble before the limits of language. Human language was created from the experience of slow bodies living on a small planet, inside a range of speeds that is extremely low compared with the light. We say travel, arrive, experience, wait, and age, because that is how our lives unfold. But light does not live that way. If we try to use everyday language to ask what light feels, we can fall into confusion. Light is not a mind having an experience. It does not sleep, remember, or wait. It has no youth and no old age. It is simply light, and for that very reason, it forces us to expand the way we think about time. One beautiful piece of evidence for time dilation comes from tiny particles called muons, which are created when cosmic rays collide with Earth's atmosphere. Based on their very short lifetime when at rest, many muons should decay before they have time to reach the ground. But because they move close to the speed of light, their time is dilated in the way observers on Earth measure it, so many of them still reach detectors on the ground. Those tiny particles are like quiet messengers confirming that time truly depends on motion. This is not just an idea inside Einstein's mind. It appears in experiments, in measurements, and in the way particles live longer when they move very fast. But even muons are not light. Muons have mass. They have proper time. They can decay after an amount of time measured in their own frame. They only show us that when an object with mass moves very fast, time measured from the outside can become powerfully different. Light sits at an even more special limit. Light has no rest mass and no rest frame. So we do not say that a photon ages more slowly like a fast-moving astronaut. More accurately, we say that the proper time along the path of light is zero. This difference is subtle, but it matters greatly. It keeps our story both beautiful and correct. Another very practical example is satellite navigation. Satellites orbiting Earth carry extremely precise clocks. They move fast, so the effect of special relativity makes their time run a little slower than clocks on the ground. But they are also higher up, in a weaker gravitational field, so the effect of general relativity makes their time run a little faster. Both effects have to be taken into account for satellite navigation systems to work accurately. If relativity were ignored, errors would accumulate. This is beautiful because it shows that ideas that seem to belong only to the distant universe are actually quietly present in everyday technology. Every time people use signals from satellites to find their way, a very small part of Einstein is working in the background. But in this sleep-friendly story, the important thing is not to overwhelm the listener with formulas. The important thing is to feel the shift in perspective. Before understanding relativity, we might imagine the universe as a large house where every clock runs to the same beat. After understanding a little, we begin to see that every motion is a different way of moving through space-time. Every object with mass has its own proper time. Every journey does not only move through space, it also moves through time in its own way. And light, because it always travels at the speed of a light in a vacuum, stands at a special boundary, not like a walking person, not like a spaceship, not like a rock, not like a body. It does not experience age the way things with mass do. Imagine life as a thread embroidered onto the fabric of space-time. The thread of a human life is soft, long, and full of curves, carrying heartbeats, memories, sleep, childhood, adulthood, loss, and peace. The thread of a planet is a vast orbit around a star. The thread of a fast spaceship may tilt in a different way, causing its proper time to be less than the time of those who stayed behind. But the path of light is like a thread pulled tight along the very edge of that fabric. It connects the event of emission and the event of absorption with no proper time between the two ends. Seen with the eyes, it is a beam of light. Seen through geometry, it is a special path in space-time. This is why light from a distant galaxy can feel so bewildering. According to our clocks, it may have travelled for millions or billions of years. During that time, countless events may have happened on Earth. Oceans changed shape, mountains rose and then wore down, life transformed, species appeared and disappeared. Human beings emerged, learned to look at the sky, learned to ask questions, and learned to build telescopes. But that light does not carry a body through those events. It is not older because Earth has changed. It simply arrives when it arrives, and when it meets an eye or a telescope, it gives us one piece of information from a very distant place. Perhaps this is one of the feelings closest to spirituality that science can offer without leaving the truth. Not spirituality in the sense of needing to believe something vague, but the stillness that comes when we realize reality is deeper than everyday feeling. We live in time, we love in time, we lose in time, we age in time. But light, the thing that allows us to see all of that, does not pass through time the way we pass through it. It stands like a boundary, a reminder that there are layers of the universe unlike the bodily experience of human beings. And when we understand that, we do not feel separated from the universe. We feel the universe teaching us a very gentle lesson. Not everything ages in the same way, because not everything lives within the same kind of time. Let us place two images side by side. On one side is a human hand, which over many years has gained more veins, wrinkles, tiny scars, sensations of warmth and cold, and the habit of touching a cup in the morning. That hand has a history. It has held, released, worked, comforted, trembled, and been strong. On the other side is light travelling through the emptiness between stars. It has no hand, no scar, no memory. But it can touch that hand, reflect into the eye, and allow the hand to be seen. The human being is where time leaves its marks. Light is what makes those marks appear. One ages because it has an inner life. The other does not age like that because it does not carry the proper time and biology of living matter. In relativity, there is another idea that forces us to give up the habit of thinking that the present is one slice shared by the entire universe. Two events that happen at the same time in one frame of reference may not happen at the same time in another frame that is moving relative to it. That means, at the same time is not as absolute as we tend to imagine. This does not affect cooking dinner or listening to rain in any noticeable way, because in daily life, our speeds are too small. But on the scale of light and the universe, it completely changes how we understand reality. If simultaneity is not absolute, if time depends on motion, and if gravity also changes the rhythm of clocks, then the age of matter cannot be understood as a simple number placed outside everything. Age is always tied to a path through space-time. For human beings, that path is life. A person may not travel far through space. They may live for many years in the same house, on the same street, beside the same garden. But in space-time, that person is still moving. Each day is a section of the journey. Each heartbeat is a tick of a personal clock. Each sleep is part of the path. Even without flying into space, we are still travelling through space-time with our own bodies. And because we have mass, biology, metabolism, and memory, we age along that path. Light does not travel like that. It has no home in time to return to. It has no birthday. It has no age. This should not make us sad, because not aging like light also means not living like a human being. Light has no loss, but it also does not know love. Light does not fear time, but it also does not know how to cherish a peaceful evening. Light has no old age, but it also has no youth. It has no first memory of the sky, no sound of an old voice, no feeling when a familiar room suddenly softens the heart. We may age, but because we have proper time, we also have experience. Time changes us, but it also gives us a story. Light helps us see that story, but it does not carry a story the way we do. So when we say light does not age the way we do, we're not saying that light is higher than life, and we're not saying that human beings are lower than light. We're simply seeing two different forms of existence. Living matter with mass passes through time by way of biological processes. Light moves through spacetime as electromagnetic radiation with no rest mass, no rest frame, and zero proper time along its path. One side is the flow of life, the other is the boundary of speed and information. One writes the years into the body, the other brings images from far away so that body can see them. By this point, what we have touched is no longer only physics, it is like a very quiet door. If light from a distant star can cross billions of years according to our clocks, while having no proper time along its own path, then when we look at Starlight, are we seeing the past of the universe, or are we touching something that almost sits outside age? Perhaps the answer lies between those two things. For us, Starlight is the past, because it left its source long ago. In the nature of light described by relativity, it does not age like an object with mass along the way, and it is precisely the meeting between the distant past and the present of our eyes that makes the night sky a place where time both appears and dissolves. Now let that question settle for a moment, like a small stone falling into the surface of a night lake. When we look at a star, we often think we are looking at a bright point in the sky. But in truth, at that moment, our eyes are receiving something that left a very distant place long before it ever touched us. Maybe it is light that left a star before modern cities existed. Maybe it is light that left a galaxy when Earth was still very different from what it is today. Maybe it is a message that has travelled through darkness for so long that every human lifetime on the ground is only like a thin mist passing briefly below it. And then, strangely, when it arrives, it does not arrive like an old pilgrim. It does not gasp for breath, it is not exhausted, it does not carry the wrinkles of the journey. It simply touches our eyes, silently lights up, and becomes an image inside the brain. If a star is 1,000 light years away from us, that means light from that star needs about 1,000 years, according to our clocks, to reach Earth. When we see it tonight, we're not seeing it exactly as it is in its own present moment. We're seeing the light it emitted 1,000 years ago. If that star is 1 million light years away, we are looking at an image that left that place 1 million years ago. If it is an extremely distant galaxy, its light may have begun its journey billions of years ago, when the universe was much younger. So the sky is not a photograph of the present. It is more like a library of time, where each bright point is an old page sent to us slowly at the fastest speed nature allows. The strange thing is that the word old belongs to us. We call that light ancient because our clocks, our history, and the distances of the universe tell us that it has travelled for a very long time. But light does not age like a body during that journey. A person passing through 1,000 years is impossible in ordinary life, because the biological body would change, weaken, and then come to an end. A material spacecraft on a long journey could be damaged, worn down, harmed by radiation, and marked by temperature and time. A piece of paper sent across many centuries could decay, yellow, and tear at the edges. But a beam of light in a vacuum has no skin to dry out, no bones to grow tired, no cells to age, and no biological memory to grow heavier with the years. Imagine a person walking across a desert. On the first day, that person is still strong. After many days, the lips dry out, the skin burns under the sun, the steps slow down, the body loses water, and the mind fills with memories of every stretch of road already crossed. The journey is written into the body. Now place beside that image a beam of light travelling through the space between stars. That space is wider than every desert on Earth. It is colder than any winter night we have ever known. It is so empty that there can be enormous distances between particles of matter, but light does not cross that place the way a person crosses a desert. It does not need food, it does not need water, it has no muscles to weaken, it has no mind to feel fear. It is electromagnetic radiation, the transmission of energy and information, continuing its journey until it is absorbed or interacts with matter. So when we say starlight has travelled for billions of years, we need to understand that this is a way of speaking from the perspective of an observer with a clock. For us, there is a very long span of time between the moment the light leaves its source and the moment it reaches an eye or a telescope. During that span, on Earth, mountains may rise and then wear down, oceans may change shape, living species may appear, develop, and disappear. Civilizations may be born and then fade away. But light does not carry those events in its body, because it does not have a body in the sense that a living creature or an ordinary object does. It does not know that on a small distant planet lives have come and gone while it has been travelling through space. This difference makes the night sky much deeper than it first appears. A star is not just a bright point. It is a moment that left its luminous source and is arriving to us after an enormous delay. When we look up, our eyes are not only looking into space, they are also looking into time. The moon we see is not completely the moon right now, because light from the moon also needs a little more than 1 second to reach us. The sun we see is the sun from about 8 minutes ago. Nearby stars may be the past from a few years, a few decades, or a few centuries ago. Distant galaxies are the past from millions or billions of years ago. Every look up at the sky is a journey backward into history, not through a time machine, but through the very speed limit of light. There is a very strange feeling that comes with thinking about this. If a very distant star has gone dark, its final light may still be on the way to us. One day, we may still see a star whose source has already changed long ago. Not because the universe wants to deceive us, but because information needs time to cross distance. Light is the way news travels through the universe. Without light, distance would only be silence. With light, the past can send a sign into the present. But that sign does not arrive like a storyteller aging along the road. It arrives as an amount of emitted radiation, travelling through space, then becoming a signal when it meets an eye, a telescope, or a very sensitive detector. Picture a letter that is not made of paper. The sender may have left the house long ago, the house may have changed owners, the road in front of the door may no longer look the same. But that letter is still travelling, with no envelope, no ink, and no wrinkled paper corners. It carries information through wavelength, frequency, intensity, direction of travel, and the traces of interactions along the way. Light from a star is like that. It is a letter with no age in the biological sense. The sender may have changed. The star may truly have aged, because a star is matter with mass, nuclear reactions, and an evolutionary process. But the light that has left it does not age like a living body while crossing the emptiness. This also helps us distinguish between the age of the light source and the age of the light itself. A star can be old. It can burn fuel in its core, change temperature, expand, contract, or end its stellar life in different ways depending on its mass. A light bulb can grow old because its filament wears down or its components degrade. A candle can burn lower and lower. The source of light is matter, so the source of light has history and age. But the emitted photon is not a tiny piece of the star's body carrying a biological aging process. It is an emitted amount of electromagnetic energy. Once it has left the source, it does not continue aging like the source. It simply travels, or it changes when it interacts with a medium and with space-time. We can imagine a star as someone writing letters in light. Throughout its life, the star sends out countless messages. The earliest messages may have already travelled very far. Later messages leave later. If the star changes colour, temperature, or surface composition, the later messages may carry different features. But each beam of light does not age into a wrinkled version of itself. It does not accumulate days and years inside itself like a body. It has no aging mechanism. It has no metabolism. It has no cells that need repair. What changes is the source, the path, the way light interacts, and the way the universe stretches its wavelength, not some biological old age inside the photon itself. This point may sound subtle, but it matters deeply. If we call light from a distant galaxy old light, we are using poetic language. It helps the listener feel its ancient distance. But to speak precisely, that light is not old the way a human being is old. It is ancient in relation to our history of observation, because it was emitted long ago. It may be redshifted, partially absorbed, bent by gravity, or dimmed by cosmic dust, but those are traces of its path and interactions, not old age in the sense of a body wearing down. Light has no face to fade, no hand to tremble, no heart to weaken. It does not carry time the way we carry time in our blood, our breath, and our memory. And on a deeper level, as we touched on with relativity, the path of light through spacetime is a special path. For objects with mass, we can talk about proper time along their journey. A person sitting in a room has proper time. An astronaut on a spacecraft has proper time. A rock lying on the ground also has a path through spacetime, and an amount of proper time. But light follows a light-like path, also called a null path in the language of physics. Along that path, the proper time is zero. We should not turn this sentence into the image of a conscious photon feeling that there is no time. A photon has no rest frame that would let us ask what it feels. But the mathematics of relativity says clearly, along the path of light, proper time does not pass the way it does for matter with mass. Notice how strange this is. A beam of light may take billions of years to reach us according to Earth's clocks. During those billions of years, if we measure by the time of the universe around us, countless stories have unfolded. But the proper time of the light path itself is zero, so light does not experience its journey the way a person experiences a life. It does not move from youth to old age. It connects two events, the event of being emitted and the event of being absorbed. Between those two events, for an outside observer, there may be an immense cosmic distance. But in the deep geometry of space-time, the path of light has no proper time in which to age. We can say this with a softer image. Human beings are like books written one page at a time. Each year is a chapter. Each experience is a line of text. Each wound is a mark. Each memory is a page folded at the corner. Light is more like a bright dot connecting one page to another, but that dot does not have its own book of life. It does not write a diary while it travels. It does not stop between the stars to record that it has crossed a cold dust cloud or a wide stretch of darkness. It simply carries information and energy. When it arrives, it may open inside our eyes as a sky, but before it meets our eyes, it has no dreams, no memories, and no age. This makes Starlight one of the most beautiful images for thinking about time. It is both the past and not old like the past. It is both a sign from an ancient place and free from the weariness of a traveller. When a telescope looks deep into the universe, it does not only magnify space, it gathers light that left galaxies when the universe was young. Deep images of the sky are like looking into layers of light sediment. A nearer galaxy shows us a more recent era. A farther galaxy shows us a more distant era. Space becomes the depth of time, and light is the thread connecting those depths to the eyes of the present. But do not forget, our present will also become a path sent outward by light. The light in this room, the light reflected from a person's face, the sunset falling on a rooftop, all of it is spreading outward. Most of that light will be absorbed very quickly by walls, soil, trees, clouds, dust, or nearby objects. A tiny fraction may escape into space, growing weaker with distance and dissolving into the vast background. In theory, every illuminated moment is also an emission. The universe does not only send light to us, we also leave behind very thin traces of light in the universe. But those traces do not age the way our bodies age. The body that emits or reflects the light is where time leaves its clearest marks. There is a tenderness in this paradox. We are creatures who age, yet we are surrounded by light that does not age the way we do. Every morning, sunlight arrives and brightens the room. Our bodies may be more tired than they were yesterday, but new light still comes in its own way. Every night, ancient starlight appears, while we are at some particular age in our lives. We never look at the sky with the same body twice. Our eyes change, our memories change, the people beside us change. But the light arriving from far away does not know those changes. It simply arrives, and that indifference makes it a strange mirror for human life. We look at light to see the universe, then turn back and see time inside ourselves. If a person at the age of 10 looks up at a constellation, and then 60 years later looks up at the same part of the sky again, Light from the stars may still continue arriving, but the person looking has changed enormously. During those 60 years, how many marks has that person's body recorded? Cells have been replaced, memories have formed. Some loved ones may have gone far away, some dreams may have taken shape, while others have quietly fallen asleep. But the sky still seems silent, starlight still seems unhurried. The thing that has clearly changed the most is not that light, but the person receiving it. We are the place where time becomes emotional. This does not mean light is completely unchanging in every circumstance. We need to stay precise so beauty does not become error. Light can be scattered in the atmosphere, which is why the daytime sky is blue. Light can be absorbed by dust between stars, making some regions of the sky darker. Light can have its path bent by gravity, such as when it passes near a very massive galaxy or galaxy cluster. Light from the distant universe can be redshifted because of the expansion of the universe. But those are changes caused by environment, interaction, and the geometry of space-time. They are not biological aging. A photon does not become old and weak because it has travelled for a long time. It can only arrive, change direction, change energy in certain processes, or end when it's absorbed. Imagine music being sent across a room. If the room is empty, the sound rings clearly. If there are thick curtains, the sound is absorbed. If the walls reflect strongly, the sound echoes. We do not say the music grows old because it has travelled through the room. We say the environment has changed the sound. With light, it is similar, but even deeper, because light does not need air the way sound does. Light travels through emptiness and carries its features until it meets something it can interact with. If its wavelength is stretched by the expanding universe, the light appears redder when we observe it, but that is the universe leaving its mark on light, not light developing wrinkles inside itself. There is an image that fits this story very well. Light is an ageless messenger, and the universe is the road changing beneath that messenger's feet. Even so, that image is only a metaphor. Light is not a person. It has no feet. It has no intention. It does not remember its destination. But the comparison helps us see the difference between age and traces of a journey. A messenger who travels far will become tired, grow older, and gain more memories. A photon is not like that. If the universe stretches its wavelength, it is more like a letter whose language has been pulled by space into a deeper tone, not like a messenger becoming old. When astronomers look at light from distant galaxies, they read it like a book written in spectra. Each element can leave behind characteristic absorption or emission lines. From light, we can infer chemical composition, temperature, motion, relative distance, and sometimes even the expansion rate of the universe. This means light, although it has no memory like a human being, can still carry information. It does not remember, but it carries marks in a physical way. It does not tell stories with words, but it delivers data so the human mind can reconstruct the story. It does not age, but it allows us to see the ages of stars, galaxies, and the universe itself. This is a beautiful point. Light does not age the way we do, but because of light, we know that other things have aged. We know whether a star may be young or old through its colour, temperature, brightness, spectrum, and position in the process of stellar evolution. We know what stage a distant galaxy is in through the light it sends us. We know that the universe was once hotter, denser, and different because of ancient radiation still left behind. Light is like the ageless secretary of the universe. It has no private life the way we do, but it records the traces of other material lives. It is not made old by time in the biological sense, but it makes time visible. And when we think about it that way, the original question becomes deeply human. We often fear old age because old age reminds us that everything is finite. But light teaches us something different. Not everything in the universe passes through time in the same way. Some things age through cells, some things age through weathering, some things change through nuclear reactions, some things change colour because the universe stretches their wavelength. Some things have no proper time along their path. Age is not a garment worn the same way by every phenomenon. Age is the way an object, a body, or a system relates to its own time, energy, structure, and motion. Maybe that is why starlight brings people peace. It is not only beautiful because it sparkles, it is beautiful because it helps us realize that our lives are part of a much larger story. Our years may feel long emotionally, but compared with light from a distant galaxy, they are only a breath. And yet that breath is exactly where light is felt. A photon does not know that it is beautiful. A star does not know who is looking at it. The universe does not need human beings in order to exist. But when light touches the eye, something very special happens. The universe becomes experience. The distant past becomes present emotion. A physical signal becomes wonder, stillness, and gratitude. We can sit quietly in the dark and think about a photon that left a distant galaxy before Earth had the familiar shapes it has today. It travelled through emptiness, through regions of weak and strong gravity, through the expansion of space, through vast gaps where no sound could travel with it. According to the clocks of the universe around us, that journey is unimaginably long. But it does not experience the journey like a traveller. It does not dream of the destination. It does not fear getting lost. It doesn't feel itself growing old. It has no self to grow old. When it finally meets a detector or a pair of eyes, its energy is handed over to matter, and its story, if we can call it a story, becomes a sign inside our world of proper time. This also helps us understand why light feels both very real and almost metaphysical. It is very real because it can be measured, calculated, and used. It allows green plants to photosynthesize, allows eyes to see, allows telescopes to capture images, and allows communication technology to work. But it feels almost metaphysical because it does not live inside the patterns that everyday intuition knows. It does not stand still. It has no rest mass. It has no rest frame. It has no proper time along its path. It is a physical phenomenon, yet it opens a question that is almost meditative. Is the time we feel every night, every year, and every time we remember the past only one particular way that living matter travels through the universe? From that angle, ancient starlight is not only starlight, it is the meeting of two kinds of time. On one side is the time of the person looking, the body breathing, the heart beating, memory drifting quietly. On the other side is the path of light. No proper time, no biological old age, only the connection between emission and absorption. When the two meet inside the eye, we feel something that is hard to name. We are looking at the past, but that past arrives through something that does not age like our past. We are seeing an old image, but the light that creates that image is not an old body. It is the past according to our clocks, but not old age in its own sense, and perhaps that is why this question holds us all the way to the end. At first, it seems like a question about light, but the deeper we go, the more it becomes a question about ourselves. Why do we age? Because we are living matter, with proper time, with complex bodies that need energy and repair. Why does light not age like us? Because light has no body, no biology, no resting state, and in relativity, its path has zero proper time. So what is age? Maybe age is not only the number of years, age is the way a form of existence is written into time. Human beings are written through memory and cells. Stars are written through nuclear reactions and gravity. Light is written through its path, wavelength, interactions, and the strange silence of zero proper time. Now, if tonight you look up at the sky, try looking slowly at one bright point. Do not see it only as a star. See it as a letter without paper, a trace without biological old age, a piece of the past that has crossed emptiness to touch your present. Maybe the sender is still there. Maybe the sender has changed. Maybe that light left before so many human stories had even begun. But when it arrives, it does not ask how old you are. It simply opens quietly. And in that moment, something very far meets something very near. The ancient universe meets living eyes. Ageless light meets a body that is aging. It is that meeting that makes time feel both immense and gentle. But if light does not age the way we do, does that mean it does not change at all? The answer is very subtle. Light does not age in the biological sense. It does not grow old like a body, does not accumulate exhaustion, and has no proper time along its path. But the universe can still leave marks on it. Expanding space can stretch the wavelength of light, shifting it toward the red. Gravity can bend its path. Dust and gas can absorb part of it. So light does not age like us, but it can still carry traces of the universe. And those traces lead us to an even deeper question. If light has no wrinkles, why can it still become redder, colder, and more distant in our eyes? Imagine a guitar string stretched in the dark. When the string is short and tight, the sound that rings out is high, bright, almost crystal clear. But if we stretch that string longer or let it loosen, the sound becomes lower, deeper, as if the music has taken one more step back into the night. Light has something similar, even though it is not sound and does not need air in order to travel. Light has wavelength. When the wavelength is shorter, visible light leans toward blue and violet, and each photon carries higher energy. When the wavelength is longer, light leans more toward red, and each photon carries less energy. So if the universe stretches the wavelength of light while it travels through the vastness of space, that light can become redder in the eyes of observers. But remember this very clearly. This is not light aging like a human being. It is the universe stretching the music of light. This point is very subtle, because in everyday life, we often mix together two things: getting old and changing. A photograph left in a drawer for a long time can fade. A sheet of paper left in the sun can turn yellow. A shirt worn for many years can become frayed. Those things grow old because they are matter with structure, with molecules, with chemical reactions, with surfaces affected by light, oxygen, moisture, and heat. But a photon does not get old in that way. It has no paper to yellow, no fabric threads to fray, no skin to wrinkle, no cells to weaken. If light from a distant galaxy reaches us redder than it was when it was emitted, the cause is not that it became tired after a long journey. The cause is that the space it travelled through expanded, stretching out its wavelength like ink marks on a balloon being inflated. Imagine drawing small ripples on the surface of a balloon before it is inflated. As the balloon grows larger, the distance between those ripples also grows longer, not because the drawing itself wants to become longer, but because the surface holding it is expanding. In cosmology, light from distant galaxies can be stretched in a similar way as the space between the source and the observer expands. A longer wavelength means the light shifts toward the red. For very distant objects, the original light may once have been visible light, or ultraviolet light, but by the time it reaches a telescope, it has been pulled into the infrared range. This is why infrared telescopes can look deeper into the younger, more distant universe, where light has been stretched by the universe throughout its long journey. The National Aeronautics and Space Administration describes cosmological redshift as the stretching of light from galaxies into longer, redder wavelengths as it travels through an expanding universe. This does not deny the statement that light does not age the way we do. On the contrary, it makes that statement more precise. Light does not age in the biological sense. It does not accumulate internal damage. It has no proper time along its path the way an object with mass does, but light can still carry traces of its path. It can become redder because space expands. It can change direction when it passes near an extremely massive object. Part of it can be absorbed by a cloud of dust. It can be scattered by gas molecules, giving the sky of a planet a different colour. It can touch a surface and become heat. In other words, light does not age like a traveller, but the road can leave fingerprints on the message that light carries. There is a very familiar example. When an ambulance passes by, the siren sounds higher as it approaches and lower as it moves away. That is the Doppler effect with sound. Sound waves are compressed or stretched depending on the relative motion between the source and the listener. With light, there is also a similar kind of shift when a light source and an observer move relative to each other. If a star is moving toward us, its light can shift toward the blue. If it is moving away, its light can shift toward the red. But the cosmological redshift of distant galaxies goes deeper than the image of a vehicle moving away, because it is connected to the expansion of space itself. The space between galaxies is not simply a still stage. That stage is expanding, and the light travelling through it is stretched like a musical note pulled into a lower tone. Let this image move very slowly. A very distant galaxy emits light. That light begins its journey with a certain wavelength. While it travels, the universe continues to expand. The distances between large galaxy clusters grow. Space is not air, not liquid, not a material fabric in the simple sense. but we can use the image of a stretching fabric as a rough way to understand it. Light travels through that space, and in the process, its wavelength is stretched. When the light finally reaches a telescope, it no longer carries exactly the original color in the way we might expect. It has been redshifted. From that redshift, scientists can infer that the distant galaxy exists in an expanding universe, and that the light has traveled across a vast distance and a vast span of time according to our clocks. It is precisely because of redshift that humans know the universe is not standing still. Edwin Hubble's observations in the 20th century showed that light from many distant galaxies was shifted toward the red, and that the farther away a galaxy usually was, the greater its redshift. This became one of the important pieces of evidence for the idea that the universe is expanding. But listen carefully to this point. When we read redshift, we are not reading the wrinkles of light. We are reading the stretching of space. We are not saying that the photon has lived so long that it has changed colour like hair turning grey. We are saying that its wavelength has been stretched by motion, by cosmic expansion, or in some cases by a gravitational field. Light does not age like a human being, but it becomes a wonderful measuring tool for the age and history of the universe itself. A paper letter left for a long time can turn yellow because the cellulose in the paper reacts with oxygen and light. An old photograph can fade because its dyes have changed. A wall can become weathered by sunlight and rain. Those signs are the aging of matter. But if light from far away arrives redder, it is not red because it has yellowed. It is red because the distance between its wave crests has become longer. This image is very important because it helps us avoid a common misunderstanding. Ancient light is not week-old light. It is light that was emitted long ago according to our calendar, and during its journey, the universe may have changed its wavelength. It is an ancient message, but not an aged body. This also makes the colours of the universe feel like a kind of language. Blue is not only blue, red is not only red. In astronomy, colour and spectrum can reveal the temperature of stars, the chemical composition of gas, the motion of celestial objects, and the expansion of space. A hotter star often emits more blue light. A cooler object emits strongly in the infrared range. A galaxy moving away has light that is redshifted. A cloud of gas can leave behind characteristic absorption lines, like the fingerprints of elements. Light does not age like us, but it carries information about things that are aging, moving, forming, and falling apart in the universe. Imagine an astronomer who cannot fly to a distant galaxy. The distance is too great. A human lifetime is too short. Even the fastest spacecraft would not be enough. But light from that galaxy has arrived. The astronomer does not touch the galaxy by hand, but can touch it through its spectrum. Light passes through a prism or an analyzing instrument and is separated into different wavelengths. Inside that band of light are very thin dark lines or bright lines, like secret symbols. They reveal which elements are present in the galaxy's gas, how the galaxy is moving, and how much the light has been stretched. The universe does not speak in words, but light is its writing. And one of its most important strokes is redshift. When we say light is stretched, we also need to remember that a photon's energy is related to frequency. The higher the frequency, the greater the photon energy. The longer the wavelength, the lower the frequency and the lower the energy. So when light is redshifted, the energy of each photon that we measure is lower than it was when it had a shorter wavelength. This is not biological tiredness. A photon has no body that can lose strength. It is the physical relationship between wavelength, frequency, and energy. A lower musical note is not lower because it is older than a higher note. It is lower because its vibration is different. Redder light is not redder because it has lived through many years like a living creature. It is redder because its wavelength is longer and its frequency is lower. OpenStax explains the relationship between the electromagnetic spectrum, wavelength, frequency, and photon energy, in which shorter wavelength photons carry higher energy than longer wavelength photons. But beyond the expansion of the universe, gravity can also change the path of light. This is one of the most beautiful images in general relativity. Before Einstein, people often thought that light travelled straight if nothing blocked its path. But if space and time can be curved by mass, then the straight path of light through a region of curved space-time will also curve. When light from a distant galaxy passes near a very massive galaxy cluster, its path can be bent as if the light were passing through a giant lens. This phenomenon is called gravitational lensing. It can stretch the image of the background galaxy into arcs, magnify it, or even produce multiple images of the same object. The National Aeronautics and Space Administration describes gravitational lensing as a phenomenon in which massive objects bend space and time, causing passing light to be distorted and magnified as if through a lens. Imagine a stream flowing through a rocky area. The water is not more tired because it has to curve around the rocks. It simply follows the shape of the stream bed. Light passing near a very massive object is similar, but the stream bed here is space-time. It does not hit an invisible wall. It follows the path that the geometry of space-time allows. If a giant galaxy or galaxy cluster lies between us and a farther galaxy, the mass of the object in the middle curves space-time, and the light from the galaxy behind it is bent on its way to us. From that, we can see faint bright arcs, images stretched like drops of dew on glass. Once again, light does not age. It only carries the trace of its path through curved space-time. This makes the story deeper. Light is a message, but that message does not travel through an empty and motionless universe. It travels through a universe with structure. There are regions of space that are expanding. There are galaxies, galaxy clusters, dark matter, gas, dust, and gravitational fields. There are places where light is magnified. There are places where light is obscured. There are places where light is split into multiple paths before reaching us. When we look at an image of gravitational lensing, it is as if we are looking at the writing of light bent by an invisible hand. But that hand is not vague magic. It is mass, gravity, and the geometry of space-time. The mystery here does not exist outside science. The mystery is science itself when we look deeply enough. Light can also be absorbed and scattered. When sunlight enters Earth's atmosphere, tiny molecules scatter blue light more strongly than red light, giving the daytime sky its gentle blue colour. When the sun is near the horizon, its light passes through a thicker layer of atmosphere. Much of the blue light is scattered away, and the remaining light that reaches our eyes tends to look redder and more orange, creating sunset. Here, the appearance of light changes in our eyes not because it has aged through a long day. It has been scattered by the environment. Every glowing red evening is a small lesson that the colours we see do not come only from the source of light, but also from the path that light has travelled. There is also dust and gas in the space between stars. Even though it is extremely thin compared with the air around us, it can still affect light travelling across thousands of light years. Cosmic dust can dim or redden the light from stars behind it, because tiny dust particles scatter and absorb shorter wavelength light more strongly. This is called reddening by dust, and it is different from cosmological redshift. Both phenomena can make light appear redder, but their causes are not the same. One is related to dust and the environment along the path. The other is related to the expansion of space or relative motion. The beauty of science is that it does not only say, the light is redder, it also asks, why is it redder? Is it because of dust, motion, cosmic expansion, or gravity? This distinction helps keep the story from becoming vague. Light does not age like a human being, but light can have a history of interactions. That history is not subjective memory. It is made of measurable physical changes. If light passes through a cloud of hydrogen gas, certain wavelengths may be absorbed, leaving dark lines in the spectrum. If light passes through dust, it can be dimmed. If light travels through an expanding universe, its wavelength is stretched. If light passes near a massive galaxy cluster, its path is curved. If light touches the surface of skin, its energy can become heat or excite molecules. But none of these things is like a living body accumulating age through cells and memories. Place two images side by side. A person grows old over many years. That person's body changes from within. Cells repair themselves more slowly. Tissues lose elasticity. Memories stack on top of memories, and experience gives the eyes more depth. That is the old age of a living being. Now imagine a beam of light travelling through space for billions of years according to our clocks. It may have its wavelength stretched by the universe, its path bent by a galaxy, and part of its strength weakened by dust. But it has no inside that can age. No heart, no immune system, no tiredness, no proper time along its path the way an object with mass has. So we can say light carries the traces of the universe, but it does not carry old age like a human being. Perhaps this is one of the ideas that softens the heart. The changes in light are not signs of decline, but traces of connection. A photon from far away may have passed through regions of space we will never be able to reach. It may have been stretched by the expansion of the universe, bent by the mass of galaxies, filtered through thin clouds of gas. When it reaches a telescope, it does not describe its path in words, but its wavelengths, its spectral lines, its brightness, and its distorted shape are all whispers. Light has no memory like we do, but the universe has written signs onto it that are enough for us to read. Thanks to those signs, human beings can look back to the very early era of the universe. When telescopes look farther away, they see light that has taken longer to reach us, meaning they are looking further back into the past. Some deep observations search for galaxies that existed when the universe was very young, only a few 100 million years after the Big Bang. Those galaxies do not appear as they are now, but as they were when the light left them. Redshift helps determine how distant and ancient the signal is. This is both scientific and almost meditative. The universe allows us to see the past not through human memory, but through light that is still arriving. The European Space Agency explains that looking deep into space also means looking back in time, because light from distant objects takes a very long time to reach us. Imagine a large cave where layers of rock record different periods of Earth's history. Deeper layers are often older. Geologists read the rock layers to understand the past. The universe also has layers of time, but they are not stacked as stone beneath our feet. They are stacked as distance and light. The farther an object is, the longer its light takes to arrive and the earlier in time we see it. Redshift is like the colour of ink on those distant pages of the book. The more light is stretched toward the red, the more it tells us that it comes from a farther region, a deeper era in the history of the universe. But that page is not yellowed by age. It is stretched by the expansion of space itself. In the same way, the cosmic microwave background is extremely ancient light, left over from a time when the universe was very young, and it has now been stretched into microwaves. At first, when the universe was much hotter, that radiation had higher energy. Across billions of years of expansion, its wavelength grew longer, and the corresponding temperature of the radiation background decreased. It is not cold, because it is shivering in space like a body losing heat. It is colder in the sense that the radiation energy we measure is lower because of cosmic expansion. This is one of the major pieces of evidence for the hot, dense history of the early universe. Light does not age like we do, but ancient light can tell us how the universe has changed. This brings the story to a very deep layer. Light is both faithful and transformed. Faithful because it carries information from the source to the observer. Transformed because the journey through the universe can stretch, bend, filter, absorb, or scatter it. A paper letter can be blurred by rain, bleached by sunlight, and made brittle by time. Light is not affected like paper, but the universe can shift its voice. A sentence spoken in a high voice may reach us as a lower voice if distance and motion stretch the waves. Light emitted at a short wavelength can reach a telescope in the form of infrared light. The message can still be read, but we need to know how to decode the change. This is also why astronomy is not only about looking at beautiful images. A picture of the universe can fill us with wonder, but behind it are mathematics, spectra, corrections, measurements, and comparisons with models. When scientists say a galaxy has a large redshift, they are not only saying that it looks red. They measure spectral lines, compare their positions with their positions in the laboratory, and then infer how much they have been stretched. From there, they estimate distance, the era of emission, and the related rate of expansion. Light becomes a measuring tool for cosmic time. It does not age like a living creature, but it helps us measure the age of distant structures. Let us return to human beings for a moment. Our bodies also have signs that let others measure time. A doctor can look at biological markers. A loved one can look at a face. An old photograph can show how we have changed. But those signs are signs of change inside the body. Light is different. When light is redshifted, that sign is not the biological age of the photon. It is a sign of the relationship between the source, the observer, and the expanding universe. This makes age a deeper concept. To ask what is aging, we must ask what kind of existence it has, what internal structure it carries, whether it has proper time, and how it interacts with its environment. A star ages because the nuclear fuel in its core changes. As hydrogen in the core is converted into helium, the balance between radiation pressure and gravity changes. Depending on its mass, a star may expand into a red giant, shed its outer layers, collapse into a white dwarf, a neutron star, or a black hole. That is the old age of the light source. Light emitted from different stages of the star carries information about those changes, but the photon itself does not age like the star. It is like a message sent from someone who is changing. The sender may grow older, and the content of the message may reflect the sender's stage of life, but an electronic message moving through a network does not age like the body of the writer while it travels. The metaphor is not perfect, but it helps us separate the light source from the light. In space, there are places where light disappears completely when it is absorbed. If a photon meets a suitable atom or molecule, its energy can lift an electron to a higher energy level, or become heat, or take part in another physical process. At that moment, the original photon no longer exists as it did before. It does not die of old age, it is absorbed in an interaction. This is like a raindrop falling into the ocean. We do not say the raindrop grew old until it vanished. We say it merged into another system. A photon can end its journey by giving its energy to matter, and if that matter later emits a new photon, that is a new event, not the same older photon changing clothes. That is why, in the story of light, there are two main outcomes. Either it continues to travel, or it interacts and transfers energy. It does not have old age between those two outcomes the way a living creature does. A human being has childhood, adulthood, old age, memory and reflection. A star has stages of formation, stability, transformation and ending. A planet has geological history. A rock has weathering. But a photon does not have a life cycle like that. It has emission, propagation and interaction. When we use the word journey for light, we're using a beautiful image to make it easier to understand, but we need to remember that it is not a psychological or biological journey. It is a physical journey. This helps us understand more clearly why light can be both ancient and not old. Light from the distant universe is ancient because the moment of its emission lies deep in our past. It is not old because along the light path itself, there is no proper time the way there is for objects with mass, and it has no internal aging mechanism. It can be stretched, have its energy changed, be bent, absorbed, or scattered, but those are traces of the universe, not traces of a body wearing down. In other words, light carries no wrinkles, but it can carry a map of the road. That map sometimes reveals things ordinary eyes could never see. Gravitational lensing can help telescopes see objects that are too far and too dim, because the galaxy cluster in between acts like a cosmic magnifying glass. Redshift reveals expansion and distance. Spectral lines reveal elemental composition. The weakening of light reveals dust and gas along the path. From those changes, human beings reconstruct a story that no one witnessed directly. A photon does not remember, but it still testifies. It does not age, but it still carries evidence. It does not speak, but it can still be read. There is a very quiet beauty in reading light this way. We do not need to turn the universe into myth in order to feel that it is sacred. We only need to understand that a very faint light from a distant galaxy may have crossed more than 10 billion years according to our clocks, been stretched so much that the naked eye can no longer see it, and then fallen onto a cold mirror in space or on the ground. From that tiny signal, human beings infer an era when the first stars and galaxies were forming. A little light becomes a bridge across time, not a bridge for our feet to walk on, but a bridge for intelligence and imagination to cross. And in the middle of that bridge, light still does not age the way we do. If you are listening to this story in the dark, maybe your eyes are already partly closed, but try to imagine a very thin, colourless stream of light in your mind. It does not rush. It does not stop. It does not fear distance. It travels through an expanding universe. And because the universe expands, its own wave rhythm is stretched. It passes near regions of great mass, and its path is bent. It passes through a thin cloud of dust, and part of it is held back. It reaches an observing instrument and numbers appear. There is no voice, but there is a message. I do not age like a living creature, but I carry the traces of everything I have passed through. From there, we can also look at human aging more gently. Old age is not only weakening, it is also the trace of a path. A person may no longer be as quick as before, but in that person's eyes are seasons that have passed. The changes in the body are real, but the experiences are real too. Light has no memory. so it does not hurt because of the past. But it also does not have the wisdom of memory. It does not age, but it does not mature. Human beings grow old, but they also grow deeper in a way light will never know. When we understand that difference, the question, why does light not age, no longer makes us only admire light. It makes us look at life with greater appreciation. And this is what makes the question deeper. If light does not age like we do, then maybe aging is not only about the passing of years, but about the fact that we are made of matter, memory, and change. A beam of light can travel through the universe without longing. A human body travels through only a few decades, yet carries an entire sky of experience. Light can be pulled red by expanding space, but it has no heart to feel sad that its color has changed. Human beings can grow grey, slow down, and still have the ability to understand light, ask questions about time, and feel peace before a distant star. Perhaps that difference is the most miraculous thing of all. Light does not age because it does not live as we do, while we age because we are allowed to live in time, allowed to remember, allowed to change, and allowed to turn a distant beam of light into meaning. Perhaps what makes human beings afraid of time is not only the numbers, it is not only another birthday passing, another calendar page being torn away, or a clock quietly moving its hands in the dark. What leaves us more silent is the feeling that everything familiar is changing. Hair that was once black can slowly turn grey. A hand that was once very strong can begin to move more slowly. A room that was once full of voices can become quieter after many years. A road that was once familiar can change so much that we have to stand still for a moment before we recognise it. And in all those changes, we realise that we too are passing through time with our own bodies. Not through some distant thought, but through breath, heartbeat, the memories we keep and the things that have faded. Human beings feel age through the body before we understand it through science. We do not need to know everything about cells to know that a sleepless night makes the body feel heavier. We do not need to know everything about the nervous system to know that an old memory can return very clearly when we hear a familiar song. We do not need to see every molecule in the skin to know that the years have touched us. Age is not only in the skin, hair, bones, or breath. Age is also in the way we look at an afternoon. The same sunset when we are young may look like a promise. After we have passed through many seasons, it may feel like a gentle reminder that everything beautiful is flowing away. Time is not measured only by clocks. It is also measured by the things we have loved, lost, waited for, forgiven, and learned to let go. And that is exactly why light becomes so strange that it almost feels metaphysical. Light does not have that sadness. It does not stand in front of a mirror and realize it has changed. It does not hear an old song and remember someone who has gone far away. It does not look back at the star that gave birth to it with gratitude or regret. It does not know how far it has travelled. It does not know how long it has taken according to our clocks. It has no childhood, no adulthood, and no old age. It has no old room to return to, no letter kept in a drawer, no hand that once held on and then let go. Light does not carry the fear of aging, but because of that, it also does not have a life the way we do. This needs to be felt slowly. When we say light does not age like human beings, we are not praising light as an immortal soul. We are also not saying light is higher than life. We are only distinguishing between two very different kinds of existence. Human beings are living matter with mass, with bodies, biological processes, proper time, memory, and emotion. Light is electromagnetic radiation. In the language of quantum physics, it is photons, with no rest mass, no rest frame, and along the path of light, proper time is zero. One side moves through the world by experience. The other connects events in space-time through energy and information. One ages because it lives. The other does not age that way because it does not live in the time of matter with mass. We can picture it this way. A person sits beside a window on a quiet night. Outside there is starlight. Inside the room there is breath. Inside that person's body the heart is still beating, blood is still flowing, cells are still working, and the brain is quietly keeping some memories while letting others fade. That person has their own proper time. Even without standing up, even without going anywhere, that person is still travelling through space-time by being alive. but the starlight entering that person's eyes is different. That light may have left a distant source long ago according to our clocks, but it does not cross that distance the way a person crosses a life. It has no inside that is aging. It has no private clock like an object with mass. It has no memories slowly piling up over the years. And here is the very important balance. Light does not age like us, but light also does not know that it exists. It does not know the beauty of a rainy afternoon. It does not know the warmth of a hand resting on your shoulder when you are tired. It does not know the quiet stillness that comes when you hear a forgiving sentence after many years. It does not know how to wait for someone to come home. It does not know how an old house can soften the human heart. It does not know the smell of books, the smell of tea, the smell of earth after rain, or the feeling when a memory you thought was lost suddenly returns with great clarity. Light can travel through the universe without aging like a body, but because it has no body, it also has no inner life. We, even though time touches us, have the ability to turn time into meaning. Perhaps human aging hurts partly because we know we are aging. A yellow leaf does not write a diary about the green season that has passed. A stone slowly worn down does not miss its old shape. A star entering the final stage of its life does not sit down and grieve its youth. But human beings know. We notice the tiny changes inside ourselves. We remember a face that used to be younger. We look at an old photograph and see that time is not only passing outside in the world, but also passing inside our own eyes. Awareness makes aging deeper. We do not only age like matter, we age as a mind that knows it used to be different, but that same ability to be aware is also a gift. Because only a creature with memory can say, I have passed through, I have learned, I have loved, I have lived. Light does not have that sentence. A photon leaving a star does not know that it is a beginning. When it is absorbed by a dust particle, it does not know that it is an ending. It has no fear between those 2 points. It does not carry the question, who am I, along the way. It has no time for regret. It also has no time for gratitude. So if light does not age like human beings, that is not a victory of light over life. It is only a consequence of its physical nature. It does not belong to the biological stream where cells need repair, where bodies need energy, where memories need to be stored through neural connections, where everything changes little by little. Light belongs to another kind of existence, emitted, travelling, interacting, absorbed, stretched, bent, but not aging in the sense of a living creature passing through its life. When we understand that, we can look at the fear of aging again with more tenderness. Maybe we once thought aging was only loss, losing speed, losing youth, losing the days that once seemed so long ahead. But age is also evidence of experience. A wrinkled hand may have worked, cared, and held another hand through difficulty. A slower voice may contain more things that have been carefully thought through. Older eyes may have seen enough sunlight and rain to no longer rush into judgment. Age does not only take away, it also places inside a person a depth that light does not have. Light may not age, but it does not mature. Human beings age, but they can become wider within. This is not meant to romanticize pain or deny biological truth. The body really does age. Fatigue is real. Loss is real. Changes in cells, tissues, the nervous system, the immune system, sleep, memory, and recovery all have a scientific basis. Aging is not only a symbol, it is a specific material process. But beside that truth, there is another truth. Human beings are not merely a collection of wear and tear. We are creatures who can tell stories about what has worn down. We can turn a scar into a memory, a failure into a lesson, a season of grief into compassion. Light does not have that ability. It is not wounded by time the way we are, but it also cannot turn time into meaning the way we can. Think of a very quiet afternoon. Light passes through the window, falls onto the floor, and touches an old chair. That chair may have been there for many years. Its wood may have changed colour. Its fabric may have become worn. The person who once sat on it may no longer be the same. But the light falling there does not carry the age of the chair, and it does not carry the memories of the person who sat there. It only makes everything appear. The person looking is where the layers of time meet. In the eyes of the viewer, the chair is not only an object. It may be the place where someone once sat reading a book, where a conversation once happened, where a distant afternoon still lingers. Light reveals the chair, but memory gives the chair a soul in our experience, so light can be seen as a strange mirror. It does not age, but it lets us see the things that are aging. It does not remember, but it awakens memory within us. It has no sadness, but it can make sadness appear through the colours of a room at sunset. It has no joy, but it can make a face light up. It has no life, but life uses light to see, to recognise, to love, and to find its way. Light does not carry meaning already inside itself. Meaning is born when light meets a mind that has time. A photon does not know that it has created beauty, but when it touches the eye, the brain can turn it into sky, face, memory, and a question about existence. We can go a little deeper, but still keep the breath slow. In physics, light helps us understand the structure of space-time. In biology, aging helps us understand the structure of life. In the mind, memory helps us understand the structure of the self. These three things meet in one very simple question. Why does light not age like we do? The answer does not sit on only one level. On the physical level, light has no rest mass and no proper time along its path the way matter with mass does. On the biological level, human beings age because the body is a living system that constantly exchanges energy and accumulates change. On the experiential level, human beings feel age because we have memory, a sense of self, and the ability to compare the present with the past. All three levels together create the difference between light and human beings. The most beautiful thing is that this difference does not make human beings smaller. It is easy to feel fragile when we compare ourselves with light. Light can cross distances the body cannot even imagine. Light can arrive from an era more distant than any memory of humanity. Light does not age the way we do, but human beings have something light does not have. The ability to know that we are inside time. We can look at a beam of light and ask where it came from. We can build telescopes to read the past of the universe. We can write equations to understand proper time. We can fall silent before a star and feel our hearts open. Light travels through the universe, but human beings turn light into understanding. There is a very deep humility in that. We do not need to outrun light. We do not need to stay forever young like a mythic image. We do not need to hate our bodies because they change. The body changes because it is a living body. Every breath needs energy. Every memory needs neural networks. Every recovery after injury is a wondrous material process. If light does not age because it has no body, then the body ages because it has done something light does not do: live. It has endured cold, endured heat, awakened, grown tired, recovered, learned, loved, and hoped. It does not exist only as a signal, it exists as a story. Try to imagine a beam of sunlight touching your skin on a quiet morning. It left the sun about 8 minutes earlier according to our clocks. In the core of the sun, energy was born from much deeper processes, then went through a complex journey inside the star before finally leaving the surface as light. When it reaches your skin, part of the light is reflected, part is absorbed, and part may contribute to the feeling of warmth. That beam of light does not know who you are. It does not know whether you're happy or sad. It does not know how old you are. But your body receives it. Your skin feels it. Your eyes see it. Your mind may call it a beautiful morning. Meaning does not already live inside the photon. Meaning blooms in the meeting between light and life. In the same way, starlight at night does not know it is making someone feel peaceful. It does not know that a person is lying in a dark room, listening to a story about time and feeling everything slow down. But that light can still become a kind of comfort. Not because light intends to comfort us, but because the human mind can receive a physical signal and place it inside a space of meaning. When we look up at the sky, we do not only see bright points, we see distance, we see the past, we see our own smallness. And strangely, inside that smallness, we feel lighter. Because if the universe is that vast, if time is that deep, then perhaps our worries can be set down a little in the night. This is where science and stillness meet. Science tells us what light is, what the speed of light is, what proper time means, why objects with mass cannot reach the speed of light, and why light from far away helps us look into the past. Stillness helps us feel the meaning of those things in life. There is no need to turn light into a god. There is no need to say light has consciousness. Understanding it correctly is already wondrous enough. A physical phenomenon with no memory awakens memory in human beings. Something that does not age like we do makes us think more deeply about old age. A signal with no inner life opens up our inner life. That is mystery within the boundaries of truth. Perhaps we fear aging because we often think time is the one who takes things away. But light suggests another way of seeing. Time is also what allows every story to happen. Without time, there would be no growth, no waiting, no learning, no healing, no seed becoming a tree, no child becoming an adult, no meeting that turns from unfamiliar into beloved, no pain turning into compassion. Light does not age because it does not have that kind of time. It does not need time to become itself. But human beings need time to become human. We are not only made old by time, we are made deeper by time. Look at age as a kind of spectrum of human life. When white light passes through a prism, it separates into many colours. When a human life passes through time, it also separates into many shades: joy, fear, patience, loss, gratitude, tenderness, strength. Without time, none of those shades could appear. A person is not born already understanding all of compassion. A heart does not naturally know how to let go from the beginning. A mind cannot become deep if it has never passed through difficult days. Age, in its most beautiful sense, is the prism that reveals the deeper colours of life. Light passes through a prism and reveals colour. Human beings pass through time and reveal the soul. Of course, not everyone grows old in peace. Some lives carry much loss, some memories are heavy, some changes in the body make us sad. But even when life is imperfect, the question about light can still open a space to breathe. It reminds us that aging is not a failure of being human. It is a sign that we belong to the world of living matter. We are not photons. We were not born to fly through the universe without memory. We were born to feel a morning, to recognize a voice, to know that one day everything will change, and that this is exactly why gentle things become precious. Light loses nothing because it does not remember. Human beings sometimes hurt because we remember, but because we remember, we also know how to love. Think about memory. Memory is not a perfect film reel stored inside the brain. It is a living process that can change when we recall it, fade, strengthen, and be coloured by emotion. Memory gives time depth. A room in the present can contain many layers of the past if important things once happened there. Light entering the eyes is only a signal of the present, but the brain can place that signal beside old memories and create a feeling of familiarity. So we don't look at the world only with light. We look at the world with light plus the time we have lived. That is what light does not have. It carries information, but it does not carry subjective memory. We carry memory, so we live in a universe with meaning. If one day you find yourself afraid of time, try remembering this difference. Light does not age like you, but light also does not know it has ever been seen. You age, but you can understand light. You can lie quietly at night and allow a scientific question to become a way of soothing the soul. You can hear about photons, proper time, spacetime, and redshift, and still feel that those ideas are connected to your life, because they tell us that reality is larger than our worries, and age is not the whole story. Age is only part of being made of living matter. The rest is how we live with it, how we recognize beauty even though everything changes. Light does not age like us, but it also cannot sit down after a long day and breathe out with relief. It does not know the comfort of sleep. It does not know what it feels like to forgive itself. It does not know the silence of a room after everyone has fallen asleep. It does not know how a slowly told story can make the heart feel less heavy. Human beings know those things because human beings have time inside. We are not measured only by years. We are measured by the moments that have left marks in the soul. A few very short moments can live longer inside us than many ordinary years. This shows that human time is not only physics, it is also experience. Still, to stay close to the truth, we need to keep a clear boundary. Light has no consciousness. Light does not feel. Light does not choose not to age. Light does not carry a soul in the way human beings often imagine. It is a physical phenomenon described by very precise theories. But those precise theories themselves open up a feeling of wonder. Relativity tells us that time is not absolute in the way old intuition imagined. Quantum physics tells us that light can be described by photons. Astronomy tells us that light from far away helps us look into the past. Biology tells us that aging is a process of the living body. When we place those truths beside one another, we do not need to add anything mystical. The truth is already deep enough. So what does light remind us about existence? Perhaps it reminds us that every form of existence has its own way of relating to time. A star relates to time through the fuel in its core and the gravity holding it together. A planet relates to time through mountains, oceans, atmosphere, and rotation. A tree relates to time through growth rings, new leaves, deep roots, and the season of falling leaves. A human being relates to time through body, memory, love, fear, language, and meaning. Light relates to time in a stranger way. Along its path, proper time is zero, but for us it can connect the present with a distant past. It does not age like us, but it makes visible the things that have passed. This is why one small beam of light can become such a beautiful symbol. It is both specific and vast. Specific because it has wavelength, frequency, energy, and speed. Vast because it touches questions about time, memory, age, and existence. When a beam of light from a distant star enters the eye, it does not only create an image, it places a question in the mind. What is truly flowing? Is time flowing outside us, or are we flowing through time with our own bodies? Does light really pass through the years, or are years the way matter with mass, like us, measures the distance between events? These questions do not need to be answered quickly. We can simply leave them there, like small stars inside the mind. And perhaps, in that silence, we see life as more precious. Because we are not light, we cannot escape our own proper time. We cannot pass through life without changing. But we can live those changes with more tenderness. We can stop seeing age only as an enemy and begin seeing it as the trace of having been here. We can look at a wrinkle not only as the loss of youth, but as a fine line left behind by smiles, worries, thoughts, and many seasons of living. We can see memory not only as something that pulls us back into the past, but as evidence that we have truly touched the world. Light does not age like we do because it has no body to age, but we have bodies, so we know what an embrace is. Light has no memory, but we have memory, so an old song can suddenly make an evening feel deeper. Light has no proper time along its path, but we have proper time, so every human life is a unique path through space-time. No two paths are completely the same. No two memories are completely the same. No two ways of looking at a star are completely the same. Light may be the same physical phenomenon, but when it meets different lives, it unfolds into different meanings. So the question, why does light not age like we do, ultimately does not only help us understand light, it helps us understand age in a softer way. Light does not age because it belongs to a kind of existence with no biology, no rest mass, no rest frame, and no proper time along its path the way matter with mass has. Human beings age because we belong to another kind of existence, one with bodies, cells, energy, repair, damage, memory, emotion, and a life written day by day. That difference does not make us lesser than light. It makes us the place where light can be felt. A universe with only light, and no one to see it, would still be the universe. But a universe with living beings who can look at light has something very strange added to it. The universe begins to ask about itself. When human beings ask why light does not age, that is matter with mass thinking about something with no rest mass. That is the proper time of a body trying to understand the path of light, where proper time is zero. That is memory trying to understand a phenomenon with no memory. In that question, there is a beautiful meeting. The finite looks at the almost ageless, and from that, learns to cherish its own finiteness more deeply. So in the end, light does not age, not because it is immortal in a mythical sense, but because it belongs to another kind of existence. It does not live in time the way living bodies do. It does not accumulate years through cells and memories. It does not have a private clock like an object with mass. It is light, travelling along the path of light, carrying energy and information, then ending or changing form when it meets matter. And when we understand that, we do not only understand light, we also understand why every second we are living is so precious. Because each second is not an empty thing passing by. It is where the body is existing, the mind is feeling, memory is forming, and a human life is being written in lines that are very small, very real, very fragile, and also very wondrous. So we have travelled through a very quiet journey, but also a very distant one. From a small beam of light falling through a window frame to starlight that has crossed spaces wider than any human dream. From the silent heartbeat inside the body to the strange clock of space-time. And the original question, why light does not age the way we do, is no longer a simple question about light. It has become a doorway into the nature of time, matter, memory, and existence itself. We have seen that human beings age because we are living matter. Our bodies have cells, energy, damage that needs repair, and quiet biological processes happening inside every breath. Each passing day is not only recorded on a calendar, but also written into the skin, the heartbeat, the brain, memory, and the way we look at an afternoon and feel that it is different from long ago. We age because we truly pass through time with our bodies. Light is different. Light has no body to grow old, no cells to wear down, no heart to grow tired, and no memory to carry long years with it. It does not sit still and remember the star that gave birth to it. It does not know how far it has travelled. It has no youth and no old age like a living creature. And deeper still, in relativity, the path of light has zero proper time. That does not mean a photon has a clock and sees that clock stop. More accurately, light has no rest frame the way an object with mass does. It belongs to a kind of existence very different from ours. But the most beautiful part is this. Light does not age the way we do, yet light can still carry traces of the universe. Expanding space can stretch its wavelength, shifting it toward the red. Gravity can bend its path. Dust and gas can dim it. Matter can absorb it, or it can turn into heat when it touches a surface. Those changes are not the wrinkles of old age. They are traces of the road. Light does not grow tired, but it can tell us how the universe has expanded, how galaxies are moving away from one another, and how the distant past has sent messages into the present. If tonight you see a star, remember that that tiny point of light may be a very ancient letter. Maybe its sender has changed long ago. Maybe that star has aged, transformed, or is no longer the way it was when that beam of light first left. But the light reaching you does not carry old age like a living body. It crosses emptiness, darkness, and the silent regions between celestial bodies, then touches your eyes. And in that moment, something very far meets something very near. The past of the universe meets the private present of a human being who is breathing, listening, and feeling. And perhaps that meeting is what makes this question so gentle. Light may not age the way we do, but light also does not know how to love, wait, remember, hurt, forgive, or feel peace after a long day. We, even though time touches us, have something light does not have. We can turn time into meaning. A wrinkle can be the trace of many smiles. An old memory can be proof that we once loved. A changing body can be proof that we have truly lived through many seasons. So light does not make human beings smaller. On the contrary, it makes our lives feel more precious. Light shows us that time is not as simple as the clock on the wall. There are things that travel through billions of years according to our clocks without aging like a body. And there are human lives, much shorter than starlight, yet carrying inside them an entire sky of memories, emotions, choices, love, and understanding. Thank you for joining Drift into Quiet, knowing on this very quiet journey. If your eyes feel a little heavier now, let your mind rest. Imagine a small beam of light traveling through the vast universe, not rushing, not growing tired, only quietly carrying a message from far away. And then, in the stillness of the night, let yourself become a little lighter too. May you sleep deeply, gently, and peacefully. I will see you again in the next soft journey into knowledge.